need sort of space on par with New Hope. Okay. So to conclude, I think that the future of SIDH on embedded platforms is inevitably going to involve some sort of hardware acceleration. Okay. But it doesn't have to be much hardware acceleration, right? It's just going to be just a finite field multiplier, basically, is all that you need in terms of hardware acceleration. And keep in mind that on IoT, bandwidth is not something you can ignore, right? It really is a big problem. Bandwidth in the IoT setting involves like transmitting with a radio. That can be very expensive, even like on a per byte basis. Like the difference between, like, in my previous slide, for 2 kilobytes versus 300 or 400 bytes, each byte is so precious when you're talking about actually having to use a radio on a limited device to send them, right? So yeah, I think that there is, there is lots to do here, and I hope that myself or some of you in the audience will be a part of that. Okay. There's also some obvious future work that we can do. Authenticated key exchange, which will be discussed later in this workshop. Signatures on C-side on embedded devices. I don't know. Maybe, maybe not. So thank you for your attendance. I'll be happy to take any questions.
Thank you. Maybe one short question. Yes.
Just a clarification. So can you go back to the slide that compares all these performances in cycles? Yes, this one.
Yes.
I just want to make sure that the clock rate, if I understand correctly, for x86 is much higher than all these other.
Yes, absolutely. So the clock rate for x86 is like in the realm of gigahertz. The others are, you're probably looking at, well, Cortex M4, I believe, is 110 megahertz or something like that.
And all these FPGA probably at a few hundreds of.
Yeah, the FPGAs you can get at about 200 megahertz.
And these numbers are in cycle count.
These are cycle counts. And so if you want to read this correctly, something like this on 100 megahertz, clock speed would be like 330 milliseconds.
Yeah.
About a third of a second.
Yeah, okay, thank you.
Yeah.
Okay, it's time. So let's send the speaker. Okay, let's do the second speaker. Okay, second speaker is Travis